Okay, chapter 4.2, exponential functions and their applications. Okay, exponential functions is really simple. Okay, the exponential function with base is defined like this, f of x. So this is exponential function, right? Let's say b is a base, and base is raised to some power, x power. Then we call this exponential expression. So this is a function of x, right? Then this is an exponential function, and there's a condition, restrictions of the base. Now, if the b is less than 0, then this is no longer a function. It's not. If b is negative, then the y value will be jumping positive and negative, jumping up and down. So the restriction is b has to be always positive. Okay, b is always has to be positive. And then also if b equals 1, then 1 to the x power is always equal to 1, right? So b cannot be equal to 1. That's the condition. And then x is the exponent. Okay, the variable x should be in the exponent. So that this is an exponential function. So x can be any real number. X is any real number. But the base has a restriction. Always has to be positive, and it is not equal to 1. So all positive except 1. That's the base. All right. So y can be something like this, 2 to the x power, or y can be, 1 over 2 raised to the x power like this. So the base is positive, so that it can be, greater than 1, or it can be between 0 and 1, like this. Okay. So that's the definition of exponential function. So always keep in mind the condition. Okay, the base has to be positive except 1. That's really important. All right, then let's evaluate f of x equals 3x when x equals 2, negative 4, and pi. So when x equals 2, then we can plug in 2 for x, right? The input. The variable x is the input. So the input will be replaced by, x will be replaced by 2. Then 3 squared. So that is 9, right? How about f of negative 4? So x is negative 4. Then 3 times 3 to the negative 4th power is 1 over 3 to the 4th power. So that is 81. 1 over 81, right? Okay, how about f of pi? Actually pi is 3.14, right? 3.14. So we can plug it in 3.14, something like this, right? So 3 to the 3.3, raised to the 3.14, 1592, and so on, right? So on. Then this will be approximately, use the calculator in this case, 31.54428 something, right? So in this case, we need a calculator. All right, really simple. What you have to do is replace x, and then x is the exponent. So this is called the exponential function. All right, so let me explain a little bit more about the exponential function. Okay, look at the base. Okay, if the base is greater than 1 like this, y equals 2 to the x power. And in this case, the base is greater than 1, right? Greater than 1. So as you see this, as x increases, what happens? If x equals 0, let's plot the point directly on this xy plane. If x equals 0, then y equals 2 to the 0 power is 1, right? 1. If x equals 1, then what's the 2 to the first power? That is 2, right? 2. And if x equals 2, then 2 squared will be 4, right? 4. So it's going all the way up, right? And if x is negative 1, then what happens? Negative 1, then 2 to the negative 1. Okay, let me write it, scratch paper. Okay, if x equals negative 1, then this is equal to 1 over 2, right? 2 to the first power. So that's 1 half. So it's 1 half over here. And if x equals negative 2, then there will be 1 over 2 squared. So it will be 1/4. So half. So as you go 1 unit to the left, always the y value is the half the previous y value. right? And as you go to the right, as 2 to 0 power is 1, right? And then 2 to the first power is 2, 2 to the second power is 4. So as you go to the right, the y value is doubled. It's doubled, so the graph looks like this. So the graph looks like this. It's increasing, right? It's increasing. So this is the graph of y equals 2x. Now, please note that the base is greater than 1. This is important. Base is greater than 1, then the graph is increasing like this. All right? Okay, how about the second graph? This is graph 1, graph 2. If the base, in this case, the base is what? The base is less than 1, right? And then greater than 0. Of course, b has to be greater than 0, right? B has to be greater than 0. So, in this case, the b is less than 1. Let me rewrite it. So, in this case, b is greater than 0 and less than 1. Then what would be the graph of this? Okay, let's try it again. This is x-axis, y-axis. So, okay, for y equals 1 over 2 to the x power. So if x equals 0, then 1 over 2, 0 is 1, right? So x equals 0, then y equals 1. If x equals 1, then y is 1 half. So as you go to the right 1 unit, then the y value is decreased by half, right? Let's try one more. 1 half squared. If x equals 2, then it is 1 over 4. So as you go 1 unit to the right, then the y value is half the previous one. Half the previous one. And then as you go to the left, let's say y equals 0. Y equals x equals negative 1. Then this is, make this positive so that we can make the base reciprocal, right? Which is 2. So as you go 1 unit to the left, then the y value is doubled. Y value is doubled. So if x equals negative 2, then you can make this one positive 2. Then the base becomes reciprocal, so it's 4. So when x is negative 2, y is 4, way up there, right? Way up there. So if you connect these points, then the graph is decreasing like this, decreasing. Decreasing, all right? Something like this. All right, it looks like this. Can you see? So this is the graph of y equals, the base is less than 1. So let's keep in mind this. So if the base is greater than 1, then the graph is going up. If the graph is between 0 and 1, then the graph is decreasing function. It's very common. It's not hard. Just understand how the base works. Okay, so let's graph g of x, 3/4. So look at this. The base is less than 1, right? And greater than 0. So this implies that the graph is decreasing. Right, it's decreasing. All right. So here is x-axis, y-axis. Then let's make some table. So if x equals 0, let's find g, right? G of x. So if x equals 0, then always the exponent is 0, then the result is 1, right? X equals 0, the result is 1. If x equals 1, then 3/4 raised to the 4th, 3/4 is 3/4, right? 3/4. So let's say this is 1, then 3/4 is somewhere over here. Sorry, not this one. Y value, right? Y value. So y value is 3/4. So maybe over here, right? So if x equals 2, then what do we do? Always multiply the previous y value by 3/4. So 9 over 16, 3/4, always. 3/4. So always 3/4 of the previous one. I'll keep writing. Right? So when this one, always 3/4, x equals 3, then 3/4, and so on. How about as you go to the left, -1. So if x is -1, then what? Then this will be a +1, reciprocal. So that will be 4/3, right? 4/3. So always multiply the previous y value by 4/3. Let's say this is 2. Then 4/3 is somewhere like this, right? So we can connect these points. Like this, right? So this is the graph of g of x. So always make sure check the base. If the base is less than 1, then always is decreasing. Okay. And then also the right end is approaching the x-axis, right? This right end is getting smaller, but never touch the x-axis, because the y value, as x increases, the y value never becomes 0, but it's getting close to 0. Okay, just keep in mind that. So we call this x what? X asymptote, right? The asymptote, horizontal asymptote. Okay, next. Okay, explain how to use the graph of f of x equal to x. This is exponential function, right? It's increasing. To produce the graph of 2 to the x minus 3. Do you remember the transformation? So actually this f of x is, okay, we're going to translate the graph of 2 to the x to the units down, right? To the units down. So whenever you have something, right, f of x minus 3, that means it's a vertical translation. Right? Vertical translation. Translation means shift, right? Shift, vertical shift. So minus 3 means down, right? Vertical translation. 3 units where? Down, right? Down. If this is positive, then up. Right? So this is very simple. This is a vertical translation. So shift the graph of f of x. F of x, which is what? 2 to the x. How many units down? 3 units down, right? 3 units down. That's it. Very simple. Okay, how about the next one? How to use the graph of f of x, which is 2 to the x, to graph this one. Look at this. The exponent x. Now the exponent x is replaced by what? This x is replaced by -3, right? -3. This means, if x minus, then move, shift. This means shift the graph. Let's shift the graph 3 units where? 3 units. X minus 3, then to the right. 3 units to the right. Can you see it? So if you have something like this, x plus 3, then shift the graph of f of x, right? Shift the graph of f of x 3 units where? Left. This time left. All right? So keep in mind this. So okay, for the first one, if f of x plus something, then what do we do? Shift 3 units where? Up. Right? Okay, for this one, if x is replaced by x minus, then 3 units to the right. X plus, then 3 units to the left. So this is the graph of what? So we're going to shift the graph of f of x, right? F of x, which is 2 to the x. How many units to the right? 3 units. 3 units to the right. That's it. So let's graph it. Here's x-axis, y-axis, right? So the graph of 2 to the x is when x equals 0, y equals 1. Let me graph it approximately. So it looks like this, right? It looks like this. So that's the graph of f of x, which is 2x, 2 to the x. Now, I'm going to shift this one 3 units down. So 1, 2, 3. So negative 2, right? This is negative 2. So this one moved down 1, 2, 3 over here, and here's negative 3. So this is horizontal axis, So it's gonna be, so this point will move down 3 units over here. So the graph looks like this, right? So this is the large f of x, which is 2 to the x minus 3. All right. Okay, then let's try the next one. X-axis, y-axis. So the graph of f of x is this one, same as 2 to the x, right? Okay, now we will shift this one 3 units to the right. Shift 3 units to the right. So 1, 2, 3, right? So this point goes over here. So the graph looks like this. Right? So this is g of x, which is 2 to the x minus 3. All right, now there's a very interesting number, the letter E. Okay, letter E is actually the number, which is 2.718281828446, blah, 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 blah. So this is an irrational number. So this one does not terminate and does not repeat. So, this number comes from this expression. So 1 plus 1 over n and raised to the nth power. And then n is, if you make n is very large, like 1 million, 1 trillion, whatever. So n goes infinity, so that the e value will be, goes infinity like this. So usually we write the e value is 2.71, right? 2.71. But this is irrational number. All right, so we can write a function f of x equals e to the x. So make sure that e is a number, not a variable. Okay, e is a number, irrational number. All right. So okay, when we graph this one, look at this. Let's compare some exponential function. Okay, in this case, the base is e, right? The base is e. So the base is now e, right? E, which is greater than 1. So the graph will be increasing, right? Increasing. So let me write it. So if x equals 0, then what is the y value? 1, right? X equals 0, then it's always 1. Okay, let me write it here, 1. So if x equals 1, then y is e, right? E is 1, 2, 3, 2.71. Right, 2.71, so it's going to be somewhere like this, right? So if you graph it, then we can try like this. Like this. Okay, so this is the graph of f of x, which is e to the x. All right, then let's try another one, which is f of x, let's say g of x. Okay, g of x, let's use a different notation. G of x is 10 to the x. Okay, 3 to the x, 3 to the x power. So now base is greater than this e, right? Greater than this e. Then let's use the red color. So the graph of this is, okay, this is graph 1, right? Okay, graph of 2 is when x equals 0, then y equals 0. Same y-intercept. And then if x equals 1, then y is 3, right? Y equals 3. So somewhere like this. right? And then if x is -1, -1, then this will be the below this line. So the graph looks like this. Can you see it? So it's more narrow, more narrow. Okay, how about number 3? Let's say this time k of x, let's use h of x, fgh, right? Fgh. So h of x is this time 2 to the x. Okay, 2 is less than e value, right? E value. So if x equals 0, use this color. So if x equals 0, then y is 1. It's the same, right? And if x equals 1, then y equals 2. Y equals 2, right? 2 over here. Then if x is -1, then there will be half, like this. So the graph is now something like this. Can you see it? So it's more wider. So this is graph 1, and the red one is, this is the graph 2, right? 2, which is f of x is 3x. And then this is the graph 3, so h of x equals now 2 to the x, right? That is g of x. All right, look at this. So as x gets greater, the graph is narrower, right? The graph gets narrower, right? So as the base gets greater, the graph gets narrower. All right. So we can compare, 3 different types of exponential functions with different bases, different value of bases. All right. So as the base gets greater, of course the y value gets greater. So the graph gets narrower. Narrower means on the y-axis. Depending on the y-axis, the right side of the graph, getting close to the y-axis, right? Okay, next example is this. Okay, the large T is the temperature of a coffee, after T minutes. T minutes after the coffee is left placed in a room. Okay, and the room temperature 70 degrees Fahrenheit. So the coffee is boiled. Once the coffee is boiled, like 160 Fahrenheit, and then if you leave it on a room temperature, then the temperature will be decreased, decreasing all the way up to 70, right? 70. So once you leave the temperature formula is given like this. So once you leave it for 20 minutes, then what's the temperature of the coffee? So that is really simple. What you do is, this is the T value, right? T value. So replace T with 20 and then use the calculator to find the room temperature, large T. So what you have to do is just plug in 20, right? 20. Then this will be approximately equal to 104.1 degrees in Fahrenheit. All right, really simple. Okay, the next one is, this time when the coffee temperature of the coffee is 90 degrees, then how long will it take to become the temperature of coffee be 90 degrees? So that's what we're looking for. So in that case, we haven't learned logarithm yet, but using the logarithm we can find it. But in this case, use a graphing calculator. We cannot do anything in this case. We can't do any further. So if you use a graphing calculator, then this is the time t, and this is the temperature t. And as you see this, the graph is actually decreasing from the when x equals 0 from this point, and then it's decreasing, right? It's decreasing like this. And then it is approaching 70 degrees, okay, 70 degrees. Okay, so if you use a graphing calculator, it looks like this. And then we want to find out 90 degrees, right? 90 degrees. So 90 degrees over here, this point, right? So once you get this point, go all the way down so that you can find t. And this t will be like similarly 31.01. All right. So the coordinate of this is when you leave the coffee in 31 minutes, 31 or 01 minutes, then the temperature of the coffee will be 90 degrees. All right. So in this case, t equals 31.01 minutes. That's it. So approximately in 31 minutes, then the coffee will cool down to 90 degrees. All right, next example is the revenue function, revenue equation is given. So R is the revenue, your weekly revenue in dollars, and X is the number of weeks passed since the product put on the market. So as X passes, X is increasing, then the revenue will be, I don't know how it works, but the question is, what will the weekly revenue, this R value, approach as time goes by? So which means as X increases, then where this R value approach, right? Approach. So look at this. There is a really fun information, interesting. 8 plus 14 times e to the negative 0.3x. Look at these parts. The exponent of e is negative, right? Negative. So let me use a different color. So look at this. 14 times e to the negative 0.03x. Then can we rewrite it so that we can move this one to the denominator because the exponent is negative, right? So once we move this exponential form in the denominator, then that becomes positive exponent, right? So from this, as x approaches infinity, time goes by. So infinity means gets very large and large. Then the denominator gets large, isn't it? Then the denominator, which is e to the 0.0x, this one gets large, right? Large, very large, right? So since the denominator gets large, so the denominator gets large, right? Since the denominator gets large, so you are dividing 14 by a very large number, then this one approaches where? 0, approaches 0, right? So let me write it, approaches 0. Approaches 0. Can you see it? So this value approaches 0. So that we can write it like this. 1760 divided by 8 plus. Because as x approaches infinity, very large, time goes by, right? Then this whole thing will be 0. So that is equal to over 8. Actually it's approaching, so it's approximately, right? Approximately. So that is what? 220? 220. Right. So the revenue approaches $220. Simple, isn't it? So as the number of weeks increases, the revenue approaches $220 per week, right? Every week. All right. So if you use a graphing calculator, then it should look like this. This is X, the number of weeks passed, and the revenue, the weekly revenue is this. So it will approach where? 220. So starting from certain point, if X equals 0, is some number, right? So as X approaches, then this one approaches this horizontal line, 220. Okay. Hope you get this. All right, then please do the exercise.